Hello everyone, I'm Mohish Today we are discussing about Newton's first law of motions. So in this lecture we'll discussing about that the Newton's first law. So Galileo simple but the revolutionary ideas that on the astron's astro Aristotelian mechanics a new mechanics had to develop the this task was this task was sorry this task was accomplished almost single-handedly by Isaac Newton. So one of the greatest scientists of all times, the Newtons built on Galileo's ideas and laid the foundations of the mechanism in terms of three laws of motion that they go his names. The Galileo law of the inertia was his starting point, which the formulate as the first law of motions. Okay, it is also known as the first law of motions. So everybody can continue to be in its state to rest of uniform motions. Rest of uniform motions is a straight line unless completed by some external force to act otherwise. What is that? It means there are the if somebody is something is in the rest positions on the time it will be in rest positions and something in will be it will be in a moving positions on the time it will be in a moving positions are there. So do whenever you are not applying to the external forces are there on the time it will be a same on that. So this is the basic things are there. So everybody continues to be its state to rest of the uniform motions in a straight line unless the complete by some external force to act the otherwise. Now see here this state of the rest of uniform linear mount linear motions both the implies zero acceleration. So the first law of motions can therefore be simply expressed as if the net external force on a body is zero, its acceleration is zero. Acceleration can be non-zero only if there is a net external force on the body. It means something force is applied on the body on that time there is a no external force. There is a net acceleration is the acceleration is zero. But there is a something force is that okay something force is that on that time the acceleration is not zero. So what will happen if the net external force on a body is zero, its acceleration is zero, and acceleration can be non-zero when there is a net external force, acceleration external force on the body is not zero. So the two kind of situations are encountered in the application of this law in the practice. In some of example, we know that the net external force on the object is zero. So in that case, we can conclude that the acceleration of the object is zero. So for example, the spaceship out in an interstellar space far from all other objects and with all the rockets turned off, so has no net external force acting on it. Its accelerations according to the first law must be zero. So it is if it is in motions, the must continue to move with the uniform velocity. Okay, what is that? For example, a spaceship out in a interstellar space, so far from all other objects and with all its rocket turn off. Okay, turn off has no net external force acting on it, so its accelerations according to the first law must be zero. But if it is in motions, it must continue to move with the uniform velocity. So it means there is a no accelerations are there, but uniform velocity is that uniform velocity are there. So more often, however, we do not know all the force to be with. In that case, if we know that that an object is unaccelerated, it is the either at rest or uniform linear motions. So we can infer from the first law that the net external force on the object must be zero. So gravity is everywhere for a terrestrial phenomena. In particular, every object experiences gravitational force due to the earth. So also object in a motions generally experience functions. So viscous, drag, etc. If then on earth an object is at the rest or in uniform linear motions. So it is not because there are no force acting on it, but because the various external force cancel out. So add up to zero net external force are there. So this it means there is a no it means there are the various external force cancel out and add up to zero net external force. So consider a book at a rest on a horizontal surface. See here in the sorry. See here. So consider a book rest on a horizontal surface. So it is subjected to the two external force. See, it is a wood and the force due to the gravity. Okay, the force due to the gravity acting downwards and upward force on the book by the table normal the force r e normal the force r. So r is the self-adjusting force of this. So this is the example of the kind of situations mentioned above. So the force are not quite known fully, but the state of motion is known. So we observe the book to be rest at rest. So therefore we conclude from the first law of the magnitude r equals to equal that of w. So a the statement often encountered is since W is equals to R. So force cancel and therefore the book is at rest. So this is the incorrect reasoning. The correct statement is that since the book is observed to be rest, the net external force on it the must be zero. So according to the first law, this implies that the consider the motions of car starting from the rest, pick up the speed and then moving on the smooth straight road with the uniform speed. So when car is stationary, there is a no net force acting on it. So during the pickup, it accelerated. So this must happen due to the net acceleration force. So not it has to be an external force or there. So the acceleration of the car cannot be an account for by any internal force. So this might sound surprising. So but it's a true. So the only con conceivable external force along the road is the force of the friction. So it is the frictional force that accelerated the car as a whole. So you will learn about the frictions in section 9 5.9. So where the car moves with the constant velocity. So there is a no net force are there. So the property of the inertia contain the first law is evident it in many situations. Suppose we are standing in a stationary bus and the driver start the bus suddenly we get thrown the back with the jerk. Why? Our feet are in touch with the floor. So there if there were no friction we would remain where we were. While the floor on the bus would simply slip forward under your feet, the back of the bus would hit us. So, however, fortunately there is some frictions between the feet and floor. So, if the start is too not too sudden, so if the acceleration is moderate, so the frictions force would be enough to accelerate or our feet along with the bus. But our body is not strictly rigid body, so it is a deformable. So it allows some relative displacement between different parts. So what this means is that while our feet go with the bus, the rest of the body remain where it is the due to the inertia. So relative to the bus, therefore we are thrown the backward. So as soon as that the happens, however, the muscular force on the rest of the body come into the play to move the body along with the bus. A similar things happen when the bus suddenly stop. Our feet stop due to the frictions, so which does not allow to relative motion between the feet and floor of the bus. So, but the rest of the body continue to move forward due to the inertia. So we are thrown forwards are there. So the restoring muscular force again come into the play with the bring body to the rest. So this is our today's topic are there. Okay, then after we will discussing about the Newton's second law of motions. It is also known as the moment It is also known as the F is equals to ma. So we are discussing about in this in the next lecture. So today we are just considering here. Okay, so thank you guys, thank you so much. If any kind of problems, if any kind of doubt in this lecture, then comment in the comment box. Thank you guys, thank you so much.